Today we will discuss composition of two SHMs in the period ratio 1:2. So again it is second part, composition of two simple harmonic motions with period ratio 1:2. What is 1:2? Means time period or frequency is in the ratio of 1:2. Means frequency of one oscillator is any omega and the frequency of other oscillator is 2 omega. So it is very much clear from the topic that x is equal to any constant a into sine 2 omega t plus phi and y is equal to b sine omega t. So these are the two equations for two SHMs, first equation and second equation. This equation for first SHM, it is equation for second SHM. So first is written by x, second is y, means both are perpendicular. So both SHMs, both motions are perpendicular to each other. So x and y perpendicular and 2 omega means frequency is 2 omega twice and the frequency of second SHM is only omega. So omega is in the ratio of 2:1 or 1:2 and it is perpendicular. So this is the basic equations which are derived from the title of the article. Now again we will follow the same steps, that is we will merge these two equations x and y by using second equation in first or first equation in second. So we will simplify and combine these equations. So this is again we will follow the same steps, that is we will solve the first equation x is equal to a sine 2 omega t plus phi. So which may be written as sine a plus b, it is sine a cos b plus cos a means 2 omega t and sine phi. So this is sine a plus b, sine a cos b plus cos a sine b. So further this sine 2 theta is 2 sine omega t cos omega t. So you know that sine 2 theta is 2 sine theta cos theta into cos phi plus cos 2 omega t. So you know that cos 2 omega t 1 minus 2 sine square omega t. This is 1 minus 2 sine square omega t, this one, into sine phi. So it is clear. So I have written or solved this formula sine 2 omega t sine 2 theta and it is taken as sine cos 2 theta. Now this equation is only in single omega t. Now what is the next step? In the next step, this is x, it is the value of x. Now we will use the value of y. So what is y? Y is b sine omega t or sine omega t is y upon b. So here we will put sine omega t as y upon b and cos omega t, we will reduce this cos omega t into sine omega t. So you know that cos omega t is equal to 1 minus sine square omega t under root. So these are the same steps which we have already followed in the previous article. That is x is equal to a into 2 into sine omega t. So from equation number second, this is y upon b, this one, and cos omega t 1 minus sine square omega t. So sine square means y square upon b square and cos phi minus plus bracket 1 minus 2 sine square omega t means y upon b whole square, that is y square upon b square, and it is sine phi. It is sine phi. So I have done this step. I am basically I have put the values of y in the values of equation of x. So this is the combined equation of x as well as y. So this is x and y equation. You can simplify this equation and reduce in the standard equation. So on simplification, so you can solve this equation or simplify this equation, and finally we get, that is on simplification. So you can do this mathematical equation or solution from the book and rearrange this equation, and finally you will find that x upon a minus sine phi, x upon a minus sine phi whole square plus 4 into y square upon b square into y square upon b square, again y square upon same b square plus x upon a sine phi, x upon a sine phi, and minus 1 is equal to 0. So this is the equation, final equation, which is obtained on simplification of this equation. So on simplifying and separating x and y coefficients, and finally you will get this answer. So this is the combined equation of two SHMs. Now again we will discuss this equation or discuss the special 5 cases. First case, when phi is 0. Second case, phi is pi by 4. Third case, phi is equal to pi by 2. And fourth case, phi is equal to 3 pi by 4. And in the fifth case, phi is equal to pi. You can solve by putting turn by turn these values. So I am solving for first case. This is phi is 0, and you will get this equation x upon a minus sine 0, 0, that is x square upon a square, okay, plus this one 4 into y square upon b square into y square upon b square, and sine 0 is 0 and minus 1 is equal to 0. So this is the equation which will be get after putting phi is equal to 0. So this is the standard equation of curve having two loops. This equation of two loops. If you plot the graph between x and y, you will get two loops like this. Two loops. So this is the equation of two loops, symmetrical two loops. Similarly, you will get the second part on putting phi is equal to second part, and phi is equal to pi by 4. So you can find this x upon a minus sine pi by 4, that is 1 by root 2 and whole square, plus 4, this one 4 y square upon b square into y square upon b square, this one, and plus x upon a into sine pi by 4, again root 2 and minus 1 is equal to 0. So this is the equation which we will get after putting the value phi is equal to pi by 4, and it is again the equation of curve with the two loops, but the loops are not just like this. These are distorted loops or displaced loops. You will get x and y. You can get the two loops like this. and second part is like this. These two loops will take the shape like these two loops when we put the value phi is equal to pi by 4. Similarly, in the third case, phi is equal to pi by 2, we will get a single, just like these two loops become just parabola, just like these two loops they merge with each other, they will merge with each other. And again, when we put next case 3 pi by 4, you will again get like this two loops, and when phi is equal to pi, you will again get this type of loops. So, we will focus on the graphical shapes which we obtained on special case on putting the values of different phi. That is, first is this, like this 8 figure, and second is like this. Third one is just only single parabola, and fourth one lobe will displaced along this side, and last one is again the first and last figures are same. So this figure is when phi is 0, when phi is pi by 4, when phi is pi by 2, when phi is 3 pi by 4, and phi is equal to pi. So these type of shapes are obtained on putting different values of phi, or these figures are basically called Lissajous figures. Similarly, we can get these figures from the graphs also. If we plot the graphical representation or plot a graph between x and y by using 2 SHM, so we will consider just like 2 SHM. It is SHM1, it is SHM2. In the first case, we will split this SHM into 8 parts like this: x 0, 1, 2, 3, 4, 5, 6, 7, and again 8. These are different parts, 8 parts. I split this whole SHM into 8 equal parts, and in second case, we will split this circle in 4 parts. Why it is split into 4 parts? Because there is ratio of the frequency in 1:2. So it is twice, it is single ratio. So it is 0, 1, 2, 3, 4, and 5, 6, 7, 8. So in the second case, I split this SHM into 4 parts, 4 equal halves, 4 equal parts. It is in 8 parts. So why it is 8? It is 4 because ratio of 8 is to 2 is to 4 is 2 is to 1. So we are taking the SHM in the ratio of 2 is to 1 or 1 is to 2. In case of time period, it is 1 is to 2. In case of frequency, it is 2 is to 1. Then when trace these lines like this. So this is the same case which we have already discussed in the previous lecture. This one, and this is the case, and second, and this third. So you can compare this 0 with 0, this 0 line and this 0 line. It is 0, and first it is first, and this first is coinciding with this part. Second, this second matching, and this is second, this one second, and third, this is third, and this is third. Fourth from here, and fourth from here, and fourth from here. Again this fourth. Yes, just like this. And second, fifth, this line, and the fifth one is this line. Again fifth is this, 5, 5, and 6, 6, sixth line, and sixth this line. 7, 7 compare, this 7 and this one 7. 7, 7 is compared. And 8th, this is 8th line and this is also 8th, again this circle. So again get this type of result. So this 8 figure, we can obtain the 2 loops when the frequency ratios or time period ratios are 1:2. So this is the graphical representation of 2 SHM with the time period ratio 1:2 or 2:1. You can find the next when phase difference. This is the case when phi is 0. If we compare, phi is equal to pi by 4. Second case, the second case, the first case. So when phi is pi by 4, then a small difference in the second figure. You can get a second figure. This one pi by 4 means this one is pi by 4. So this is 0. So 0 is not lying here. 0 is lying at this point because at this position there is difference of pi by 4, 45 degree angle. And 0, this is 1. This one is 2. It is 3. So 0, 1 is 2. It is 3. It is again 4, 5, 6, 7 and again 8. So you can find again this projections along x-axis and along this y-axis. This one projection second, third and this one fourth and this last. So you can find on comparing 0, 0.11, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7 and 8, 8, you can get this type of result. You can draw this figure also from this part. And similarly, you can find third case when phi is pi by 2. Pi by 2 means 90 degree. So you will start the 0 from here because it is pi by 2. 0, 1, 2, 3, 4, 5, 6, 7, 8. You can get the next figure. Similarly, you can solve other sub cases also. So this is the graphical representation of 2 SHMs. Thank you very much.